Starting off, it says lines and circles. So for the most part, the front side is going to be review, which will be good, especially for those of you, taking the ACT and stuff. And then the back side, we're going to do some circles, which will be totally new for some of us. It'll be review for those of you that have had some pre-calc. But starting off here, we're going to start real basic. Okay, so it says solutions of an equation is equations in two variables. So real quick, what does that mean? Two variables. Two letters representing missed or unknown values. So we can see we have an x and a y. Has solutions that are ordered pairs such that when the first coordinate is substituted in for x, so we know the first coordinate's always x, and the second for y, the result is a true equation. So we need to determine if these points are a solution to that equation. So what we're going to do, we're going to take the first value and plug it in for x, and then take the second value, that's the y value, and plug it in for y, and see if the equation is true. So let's start off with 2 times, now I'm plugging in my x value of -5, plus 3 times, plugging in 7 for y, equals 18. A little substitution there, bless you. So when we multiply this out, we get -10 plus 3 times 7 is 21 equals 18. And then what's -10 plus 21? 11. Does 11 equal 18? No. So we write does not equal. And the answer to the question is no. It is not a solution to the equation. Okay, test example B on your own real quick. Some of you can probably do that in your head. It's small enough numbers, but go ahead and do B on your own. What's 6 plus 12? 18. Proud of you. 18 does equal 18. So our answer is yes. That's a yes. That says yes. The point 34 is a solution to the equation 2x plus 3y equals 18. Okay? All right. So now we're going, our goal of these two examples is to review how to graph lines. And the first way, we're going to focus on intercepts. Okay? So before we do that, I want to do a real quick just kind of example. Let me find a graph here. Okay, so which one's the x-axis, first of all? Just a quick review. Yeah, so this is x plus, right? The positive side, so this is x minus, and then up here would be the positive y and the negative y. Which one is quadrant 1?
The top right.
Yeah, the positive. That's where most of the time we do a lot of our stuff in math, in the positive quadrant. Which one's 2?
The left, top left.
Top left is 2. 3.
Bottom left.
Bottom left.
Counterclockwise.
And 4 is bottom right. So it's counterclockwise around the graph, okay? So that's just good to know. So if I say, look in quadrant 3, sometime this semester, you'll know what I'm talking about, okay? But the point of this, real quick, let's look at the x-axis. How would I write this point? That is the point over 1 up 0. Remember, we always do the x value first and then the y value, okay? What is this point? 2, 0. What is this point? Now I could go on and on and on, but what do you notice about the y values? Not only does it not change, it's always 0. So if I'm on the x-axis, y always equals 0. So lock that in your brain real quick. Now let's go over to the y-axis. How would I write this point? That is the point over 0 up 1. Guys, what is this point?
0, 2.
Over 0 up 2. and so on and so forth. So if I'm on the y-axis, what do you notice about the x values? The x values always equal 0. So they're opposites. If we're on the x-axis, y equals 0. If we're on the y-axis, x equals 0. So we can use that to our advantage on example 2. So it says graph by using intercepts. So we need to find the x-intercept and the y-intercept. So let's go ahead and do the x-intercept first. There's a little bit of space between the graphs here you can draw in. And just a second ago, we learned if we're on the x-axis, what do we already know y is? 0. So what we can do is we can rewrite this equation, 2x plus 3, but times y, we know that y is going to be 0 if I'm on the x-axis. So if we're trying to find the x-intercept, you plug in 0 for y. Now this is always super easy because that causes that variable to cancel out. And we're left with like a 6th grade equation, 2x equals 18, so therefore x equals 9. Now let's write that as a coordinate, as a point. So how would I write an x-intercept as a point? 9, 0. Now you can see I already have these graphed, but can you see how that x-intercept is 9? So go ahead and plot your x-intercept of 9. And now let's do the same thing for y, but what are we going to change? Make x 0. Good. So instead of 2x, we're going to write 2 times 0 plus, and this time we keep y, because that's what we're trying to find, equals 18. The x's cancel out this time, so we're left with 3y equals 18. Therefore, y equals, divide by 3, we would get 6. Now, as a point, how would I write the y-intercept? Over 0, up 6. So x is 0, y is 6. So we plot that. You can see I already have it up here, but put a point on the y-axis at 0, 6. And at that point, how many points does it take to find a line? All it takes is 2, because if you connect those 2, we can find any point on that line. We now know where that line is at. So go ahead and draw your line from 6 y-intercept to 9 x-intercept, and there you go. That's graphing by intercepts. Okay, now the other way that we can graph, which you're probably more used to, is graphing with the form y equals mx plus b. You've heard that since probably 7th or 8th grade. So, what does m equal? What is m? It's the slope, so rise over run. And what is the b value? The y-intercept. Now notice, this is the exact same line, 2x plus 3y equals 18. So when we graph it, it should look the same, okay? So in order to graph it, we have to get it y set equal to 0, or sorry, not set equal to 0, y by itself on the left side. So if we want this y by itself, the first thing we can do is get these x's out of the way. So I'm going to subtract over 2 x's. This is a positive 2x, so we do the opposite. We subtract it. So there's no more x's on the left, so now we have 3 y's equal. Now can you do 18 minus 2x? Can you combine those together? No, they're not like terms. One has an x and one doesn't. One is multiplied by something and one is not. So we'll just write them separately. And in this form, which term do we usually write first? The x term or the constant term? Yeah, mx plus b. So it doesn't really matter, but I'm going to write this negative 2x first plus the 18 that was already over there. Just because we usually write the x first. And now, what's the only thing left to do to get y by itself? Divide by 3. If you divide one term by 3, you have to go through and divide each term by 3. So 3 divided by 3 is 1. That cancels. We get y equals. Now, what does this represent, the number in front of x? That's the slope. And if you remember, slope is actually easier as a fraction because we want to see the rise over run. So just keep that as negative 2/3 x. Yeah, and then 18 divided by 3 gives us a nice, pretty 6. Now, we actually already knew that was going to be 6, right? Because what is that number? The y-intercept, and we actually found that over here already. It was 6 down here, right? So, we already knew that. So, go ahead and put your y-intercept at 6. So, this number is our y-intercept. This number is our slope. Now, what does it mean to have a slope of -2/3? Yeah, remember, rise is up and down, over, run is left and right. So the fact that there's a -2 on top, that means go down 2, and then a +3 on bottom. Which way is positive in the x direction? To the right. So you can see we go down 2/3, down 2/3, down 2/3, and what do we hit? 9. That x-intercept that we got from the other problem. So connect your points. And we now have our line. All right, the last thing for today is going to be the distance formula. So we're going to do these two examples and then we'll be done. So just to review, it's right here on your notes. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, does this mean x squared? What is that? That lower, that's a subscript, right? It means it's under the line. What does that mean? What's that used for in math? Yeah, the second point. So, for example, let's say I had a list of a whole bunch of points, just random points. Remember, every first number is the x value, every second number is the y value, and we use the subscript to distinguish between the points. So I could say this is the first point, and this is the second point, and this is the third point. Okay, so obviously with the distance formula, we're only going to have 2 points. So let's go ahead and label these x, y, x, y. Now, does it matter which one we call the first point and which one we call the second point? No, it doesn't matter. 2 points is 2 points. We're just trying to find the distance between. So I'm going to be crazy, and I'm going to do it backwards. I'm going to say this is the first point, and this is the second point. The order doesn't matter. We don't know which one was at first. So once you label those, all you have to do is throw it into the formula. So do a big long square root. Now let's go with the way that I labeled it. So Kenzie, what is my second x value? That's what the formula says to do first. It is -2 minus, because the formula has a minus in it. And then Peyton, what is my first x value? 30. Good. And then we close our parentheses, squared plus. Emily, I now need my second y value. What is that? Good. Y2 is 2 minus. Aiden, what is my first y value? Good. So we have a -6. Now that happens quite a bit in the distance formula where we have minus a negative because there's a minus sign in the formula and the number that comes after it also just happens to be negative. So from here on out, you can probably simplify the rest of it. What is negative? Remember, inside out. Always inside out. So what is -2 minus 3? -5 squared plus minus a negative is plus, so that's going to be 8 squared. Now this is usually the part where people mess up. Okay? Because you get lazy and you should know what -5 squared is. What's -5 times -5? Positive 25, because what's a negative times itself? Yeah, a negative times a negative is a positive. But I see this all the time, all the way through kids in AP Calculus. They'll get real lazy and just want to type everything in their calculator, and they type this. They say -5 squared. And they see a -25, and they write it down without even thinking about it. Why is that not correct? Now, your calculator is not wrong. Your calculator is right for what you typed in. But in the context of this problem, that is incorrect. Yeah, basically there's not parentheses around it. If you want to square a negative number, you have to include the negative in the parentheses. So -5 squared is different than the quantity -5, the number, times itself squared, which we know is +25. Okay? So be careful of that. Don't be lazy. Don't rely too much on your calculator. And if you are relying on your calculator, make sure you're typing it in correctly. So let me ask you this. Will there ever be a negative number in this step? No, because it's always a number times itself. So -5 squared is +25. A negative times a negative is positive, but a positive times a positive is also positive. So we get the square root of 89, not 81. So, yeah, we'll just leave it as that. The square root of 89, okay? Now, the last problem for today. How is B different than A?
It gives you the distance.
It gives you the distance.
Find the value of x.
We have to go backwards and find the missing value of x. So, this is where the college algebra part comes in. This was just geometry. We learned this a couple years ago. Now we have to apply that towards the algebra. So I'm going to use the same formula, but what am I going to plug in for the letter D?
10.
Yeah, we actually know the answer. So the number on the left side is a 10. And then square root of
-7.
Now you could do -7 minus x, but it's actually easier if you have a variable to write the variable first. Typically in algebra, we're used to having the x value first. So instead of -7 minus x, I'm going to write x minus -7 squared plus.
So
Now, if I choose to write that value first, what y value has to come first? The 11. You have to do the 11 first or it's going to be wrong. You have to keep the same order. 11 minus 3 squared. So x minus x, y minus y, keep the same order. Okay, now let's simplify what we can. So obviously we know 10 equals the square root of, what's minus a negative? What is 11 minus 3? Squared. Yeah, so we can go ahead and simplify that to a 64. Okay, now, everyone, and I was some of you were trying to do this problem on your pretest. I just wanted you to see the one that's really similar to it. I saw people doing x plus 7 squared. First of all, x plus 7 squared is not x squared plus 49. That's a big no-no. X plus 7 squared is x plus 7 times x plus 7, which is x squared plus 7x plus 7x is plus 14x plus 49. Right? You got to FOIL it out. But regardless, why is that counterproductive to what we want to do right now? Yeah, we're trying to solve for x. We don't want to make more x's. We want to solve for the one x that there is. So don't do stuff. We want to undo stuff. So instead of thinking about squaring the parentheses, what's something that I could undo on the right side? Get rid of it. Because we're trying to basically dig into this cave and get x by itself.
Well, if you take off the square root, then it's going to automatically take the square off.
Perfect. Well, be careful. You're right. So how do I undo a square root? You square it, right? You square the square root. But if you square one side, you have to square the other side. Is that what you're saying there? So what is 10 squared? Yeah, so the left side is going to turn to 100. Now be careful, nothing underneath changes. All the square does is it cancels out the square root. So now we're left with x plus 7 squared plus 64. Okay, we're getting closer.
7.
Yeah, remember we want to undo stuff. So how could I undo plus 64? Minus 64. That gives me 36 equals x plus 7 squared. Now we're undoing stuff. How do you undo a square now? You square root it. So up here we squared a square root. Now we're going to square root a square. So the square root cancels out the square. So there's only one x plus 7. So you don't need the parentheses anymore because it's not being squared. Now be careful, it does equal 6, but it also equals negative 6. Plus or minus, you remember that? The reason for that, what is 6 squared? 36. What is negative 6 squared? It's also 36. So if I want to go backwards to where I came from, if we want to take the square root of 36, we have to include both possibilities that when you square them, gives me the number 36. Does that make sense? So that's why there's two answers, because two answers squared give me 36. Now that's a big deal because we're going to get two answers out of this problem. So this is basically 6 equals x plus 7. So positive 6 equals x plus 7. But it's also negative 6 equals x plus 7. Positive and negative 6 equal x plus 7. So what answer am I going to get out of the left side here if I subtract this 7 over? Negative 1. And if I subtract this 7 over, x equals negative 13. Okay, now real quick, before you pack up, I want to explain what the heck just happened. Because that was kind of crazy, right? There's our original problem. I lost it. So we got negative 13 and negative 1. So I'm going to clear all this junk out of the way. We got negative 13 and we got x equals negative 1, right? Okay, so let's take a look at this real quick. What is the only point that we really knew from the beginning? Negative 7, 3. So I'm going to plot that. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. It's right here, right? Now, our whole goal was to find this point. But how many points did we actually find in the end? We found two different answers. So if I plug in the x values for what I just found, one of them is negative 13, 11. But we also found another x value, right? We also found negative 1, 11. So we found two values of x that work. So watch what happens when I plot these points. So 3, 4, 5, 6, 7, 8, 9, 10, 11. So here's negative 1, 11. Here's negative 7, 8, 9, 10, 11, 12, 13. Negative 13, 11. What do you notice about those two red points? They're the same distance away from the blue point. They're both 10 units away from the blue point. That's why there's two answers, because there's 2 points at the y value of 11 that are 10 units away from that point. Okay. Now, why is there not 4 points? Why can't I include these down here? Because those would also be 10 units away, right? We get an x. Yeah, because what did they say the y value has to be? 11. Not the negative 1. So there's 2 points that are 10 units away from that point that are also at the y value of 11. So that's what we just found. Okay? All right, that is all for today.